We want to use mesh analysis to write some equations from which I can find this voltage V. Well, obviously the first thing to do is set up our mesh loops. Redraw the circuit with the sources killed. So the current source becomes an open circuit, the voltage source becomes a short circuit. Then determine any resulting enclosed non-overlapping areas. So I have one up here, one down here, and one over here. The current source here keeps this side from being enclosed. So now I'll define my mesh loops. I'll put I1 up here. I'll put I2 down here, and I3 will go around this rightmost area. Now I need a constrained loop to account for this 3 amp current source. I think I'll run my constrained loop around this right section here, 3 amps. So now that accounts for the magnitude and direction of this current in the current source. Now I just write KVL around my 3 mesh loops. So loop 1, if I start over here, I see my 3 ohm resistor first. The current through that is I1 plus 3 amps. They're both in the same direction, plus 4 ohms times I1 minus I3 plus 12 volts is equal to 0. Mesh loop 2, if I start down here, 5 ohms times I2 plus 3 amps. Those are both going in the same direction through the 5 ohm resistor, minus 12 volts plus 6 ohms times I2 minus I3 equals 0. Finally, loop 3, if I start down here again, 6 ohms times I3 minus I2 plus 4 ohms times I3 minus I1 plus 7 ohms times just I3 is equal to 0. Finally, I need an equation that describes V in terms of my mesh currents. So V is equal to 4 ohms times the current going through that. Now, in all of these up here, for any given loop, I've assumed that the loop that I'm following enters the positive voltage terminal. I can make that choice arbitrarily. For finding V, though, I have to stick with the polarity that's assigned in the problem. So V is 4 ohms times I3 is entering the positive terminal this way, and I1 is entering the negative terminal. There's my 4 equations and 4 unknowns. Now notice that I completely ignored the assigned voltage polarity when I write KVL. Some people, when they're doing this, they want to keep this polarity for V because they think there's something special about it, which there isn't. Let me see how that works if I decide to do that. Make myself some extra space up here. So let's rewrite loop 1. So an alternate approach for loop 1. I can still start over here. I have 3 ohms. I can choose my polarity arbitrarily. I'm going to assume that this is my polarity. So it's going to be I1 plus 3 amps. Now if I want to account for this voltage with this negative polarity, I can say I have a negative contribution. I'm seeing the negative terminal of V first. So it's 4 ohms times the currents through that. However, the signs on these currents, I1 and I3, have to be selected according to the same sign convention you used to get this sign out here. So now I1's entering the negative terminal and I3 is entering the positive terminal. Then I see my plus 12 volts. And this gives me exactly the same equation that I got for loop 1 before, because if I rewrite it, so plus 4 ohms, bringing this sign in here, I1 minus I3 plus 12 volts is equal to 0. Another alternate, if you want to, you can just keep the variable name V. So if I do 3 ohms times I1 plus 3 amps, I see the negative terminal on V, so minus V plus 12 volts is equal to 0. And then I write another equation for V, which is the same one that I have down here. V is equal to 4 ohms times I3 minus I1. If I substitute this in up here, I get the same thing that I got up here. As long as you're consistent, it doesn't matter. One thing you don't want to do is mix yourself up. This is bad. So I'm going to be careless, and I'll come around here and I say I have 4 ohms times I1 plus 3 amps. Oh, and then I see a negative terminal here for V. So I'm going to subtract that off. But then always before, we've taken the resistance, 4 ohms, and multiplied it by this mesh current minus I3 plus 12 volts. This guy's sign is wrong. We've started out with one voltage convention, that we're entering the negative terminal, but then we forgot about that when we decided what the voltage actually was across that element. Don't do this. Pick a sign convention, stick to it, and you'll be fine.